from 1 to X is played on a rectangular grid divided into regions. Your goal is to fill these regions with numbers from 1 to X, where X is the number of cells in the region. Same numbers from different regions cannot be orthogonally adjacent. The numbers on the edge of the grid show the sums of values in their corresponding row or column. Considering there's no requirement for the numbers to be unique within a row or column, this puzzle requires some extra tricks to solve. However, it's not as hard as you might imagine. For example, take a look at this row here. It consists of one full region and 3 out of 4 cells of another region, and we know the sum of these 6 cells is 14. According to the puzzle rules, these 3 cells are 1, 2 and 3, so they sum to 6. This means these 3 cells must sum to 8. We also know the 4 cells in the region are 1, 2, 3 and 4, so our only way to get 8 out of these 3 cells is if they are 1, 3 and 4, meaning this cell here is a 2. Now let's take a look at this row here. It has 6 cells total and we already know 3 of them, and we can see they sum to 11. The sum of the remaining 3 is 27 minus 11, so 16. Now let's check the maximum values of these 3 cells here. This cell belongs to a region that is 7 cells big, but the 7 is already on the board, so its maximum value is 6. This cell belongs to a 5-cell region, so its maximum is 5. This cell also belongs to a 5-cell region, so its maximum is 5. 5 plus 5 plus 6 equals 16, so there's no way we can achieve 16 with any other values, meaning we can fill these 3 cells. This cell is the last one in its region we don't know yet, meaning it must be a 3. Now let's look at these cells. Since both the 6 and the 7 from the 7-cell region are located in column 2, we know that the 3 missing cells are 1, 3 and 4, so the total of its cells in the first column is 1 plus 2 plus 3 plus 4 plus 5 equals 15. This means this cell here must be a 4. This makes this cell the last one in its region, so it must be a 3. Now let's look at these 3 cells. We know the remaining cells in this column sum to 4 plus 3 plus 1 equals 8. This means these 3 cells must sum to 14 minus 8 equals 6. Now let's consider our ways to make a 6 out of 3 non-unique values. There's the most popular option, 1 plus 2 plus 3, but otherwise there's also 2 plus 2 plus 2 and 1 plus 4 plus 1. Considering same values can't be orthogonally adjacent, we can exclude 2 plus 2 plus 2. 1 plus 1 plus 4 is a bit more complex, but it also can be excluded, because this cell has an orthogonally adjacent 1, and this one already has a 1 in the same region. So 1 plus 1 plus 4 would require us to place 2 ones, but we don't have 2 cells to place them. So we only have one combination left, 1 plus 2 plus 3. And since we already ruled 2 out of the 3 cells in the column as possible positions for a 1, it must be located in the remaining cell. Additionally, this cell can't contain a 3 because it already has a 3 in the same region, so it must be a 2, and the last one is a 3. This cell is now the last empty cell in the region, so it must contain a 3. Now let's look at this column. We know the 2 missing cells in this region are 1 and 4. This means the total of the column except for this cell is 5 plus 4 plus 1 plus 3 plus 3 equals 16. Therefore, this cell must be 23 minus 16 equals 7. Now let's look at this region here. Or, more specifically, our options to place a 2 in it. These 4 cells each have an adjacent 2, meaning our only option for a 2 is this cell. Now this row here. The already known cells sum to 2 plus 1 plus 3 plus 7 equals 13, so the sum of the 2 missing values is 18 minus 13 equals 5. We have 2 ways to make a 5 out of 2 values, 2 plus 3 and 1 plus 4. Considering both of the cells have an adjacent 2, the only working option here is 1 plus 4. This cell already has a 1 in the same region, so it must be a 4, while this one is a 1. Now this column here. The known cells sum to 2 plus 2 plus 1 plus 3 equals 8, so these 2 cells must sum to 16 minus 8 equals 8. We know both the cells belong to a region of size 5, so our only way to make a 8 of 2 different values that are 5 or below is 3 plus 5. We don't know which of the 2 is which, but now let's take a look at row 3. The value of the 3 known cells is 7 plus 3 plus 1 equals 11. Let's say the cell with the 3 or 5 value is also unknown, meaning the total sum of the 3 unknown cells is 19 minus 11 equals 8. But let's try to check the minimal values of the 3 unknown cells in question. This cell here already has a 1 and a 2 in the same block, so its minimal value is A3. We have already established this cell is A3 or A5, so its minimal value is A3. This cell here can't be 1 because it has an adjacent 1, so its minimal value is A2. 3 plus 3 plus 2 equals 8, so there's no way we can get 8 using some different values. Since we already found the 3, this cell must be a 5. This cell here is the last one in its region, so it must be a 4. This cell must be a 1 or A4, but considering it has an adjacent 4, it's definitely A1. This means this cell is A4. This cell is the last in its row, and the known values in the row sum to 4 plus 1 plus 5 plus 4 plus 3 equals 17, meaning it must be a 4. This makes this cell the last one in its region, so it must be a 1. This cell is the last in its column, and the known cells sum to 6 plus 1 plus 7 plus 2 plus 1 equals 17, meaning it has to be 23 minus 17 equals 6. And this cell is the last in its block, meaning it contains a 5. That sure took a while. Feel free to check the other videos on our channel for tutorials to different kinds of math and logic puzzles.